Welcome back, friends. Today we are going to discuss about the chemical properties or the chemical reactions of alcohol. In the previous session, we discussed about the laboratory preparation of alcohols, and I told you that this session will be somewhat longer because alcohol, they undergo different categories of reactions. So let's go. In the chemical reactions or the chemical properties of alcohols, we are defining these. We are grouping these reactions into groups. The first, we are looking at the reactions involving a hydroxyl group, the functional group of alcohol. Then we'll look at the redox reaction, that means the oxidation reactions of alcohols to carbon compound or carboxylic acid. And then in the third group, we'll look at the reactions involving the acidic beta, hydrogen, and hydroxyl group. They involve two groups together, acidic beta hydrogen and hydroxyl group. Now let's start with the first group of reaction. They are the reactions which involve hydroxyl group. Reactions which involve hydroxyl group. Reactions which involve hydroxyl group. So tunachokisema ni kwamba reactions involving replacement of hydrogen from hydroxyl group. This takes place when alcohol are treated with a dry alkaline metal and give alkoxide salt. So kwenye hii group kwanza tuna reactions ambazo zina replace hydrogen. Reactions which replace hydrogen from hydroxyl group to give alkoxide salts. So kwenye hii reaction tukiwa tuna compound kama ROH, which is our alcohol, and then we treat it with the metal M in the place of dry ether, tutapata compound ambayo ni R, then OM plus hydrogen gas. Kwa hiyo hii hapa ndio inaitwa alkoxide salt. It is RO then M, alkoxide salt. The reaction inatokea under dry, it's not under dry ether. Hapa tunatumia heat. Ila tunatakiwa tuwe tuna dry alkaline metal. Huyu metal lazima awe ni alkaline metal, kwa sababu sio metal zote zinaweza kaandago reaction kama hiyo hapo, zinaweza kaandago reaction kama hiyo. Alkaline metals simply they are group 1 metals. So group 1 elements. Kwa hiyo tutakupa mfano tuna CH3 CH2 hydroxy plus sodium in the presence of heat, tunakuja kupata CH3 CH2O sodium plus half hydrogen. So this is named the sodium alkoxide. Lakini for example, we may have benzyl alcohol CH2 hydroxy plus potassium in the presence of heat. We get a benzyl alcohol ambayo itakuwa na CH2O potassium plus a half hydrogen. Kwa reaction inakuwa inatokea kwa namna kama hiyo, So when alkoxide salt is hydrolyzed by water, an alkali and alcohol are formed. So kama tukimchukua alkoxide salt ambayo imekuwa formed alkoxide salt ambayo imekuwa formed Kimchukua alkoxide salt, let's say ni ROM, tukamhydrolyze na water, tutapata RO hydroxide plus M hydroxide. Wakati hapo itakuwa ni alkaline solution, yani base. For example, tukiwa na CH2O sodium tukamhydrolyze na water, tutakuja kupata CH2 hydroxide plus sodium hydroxide which is alkaline solution. Kwa hiyo hivyo ndio vitu ambavyo vinakuwa vinaenda kwenye hizo reaction za alcohol. Hiyo ni reaction ya kwanza ambayo ni reaction with the dry alkaline metal in the presence of heat to get alkoxide salt. Unakuwa unapata alkoxide salt. Kwa hiyo ni reaction ya kwanza ya alcohol. From there reaction ya pili, reaction involving replacement of hydroxyl group. Reaction involving replacement of hydroxyl. Kwa kuna reaction ambazo hydroxyl yote inatoka. Na kwenye hizi reaction, when alcohol is treated with the halogenating agent, the hydroxyl group is replaced with the halogen to form alkyl halide or haloalkane. So the halogenating agent, they involve phosphorus pentachloride. Then we have phosphorus trichloride, which is phosphorus. And then you have another which is thionyl chloride. Sulfur, or sometimes we call it the thionyl chloride. Sulfur thionyl chloride. So it is SO2. Sasa kama tukichukua alcohol tukimreactisha na hizi hapa, product wanapokuwa formed wanakuwa na differ. The reaction of alcohol with this reagent produce different products and the same condition reactions. So let's say we have an alcohol ROH, then to reactisha with this reagent. Reactisha na hizi reagent. So hapa tukiwa tuna SO chlorine 2, tukiwa tuna P chlorine 3, na tukiwa tuna P chlorine 5. Hapa tukiwa tuna R chlorine. Yani namaanisha kwamba tukireactisha huyu na huyu hapa tutapata huyu hapa atakuwa replaced na chlorine, lakini also will have sulfur dioxide gas and will have hydrogen chloride in the product. Lakini tukireactisha huyu na huyu hapa trichloride tutapata 3R chlorine ile pale. Manake hizi zikiwa tatu zitakuja kutengeneza hawa tatu. Alafu from there tutapata H3PO3. Lakini tukireactisha huyu na pentachloride, phosphorus pentachloride, tutapata R chlorine plus PO chlorine 3 plus HCl. Now, unaweza kuona kwa mfano hapa chlorine tatu zote zimeenda kutengeneza 3 molecules of haloalkane. Hapa chlorine tatu ni ameenda kutengeneza haloalkane mmoja tu. Chlorine tano haloalkane ametengenezwa mmoja. Hapa chlorine tatu zimeenda kutengeneza huyu hapa na chlorine nyingine ile pale. Hapa chlorine mbili, mmoja tu haloalkane ametengenezwa. Hapa chlorine tatu zote zimeenda kutengeneza haloalkane. So you can observe yourself the difference in products when we are using different halogenating agent in this reaction. Kwa hiyo inategemea tutatumia halogenating agent gani, lakini kila agent itatupa reaction yake. Kila agent itatupa reaction ya aina yake. So hii zote reaction product tunayoibase hapa ni haloalkane ndio tunayoitazama, lakini we have different categories of reaction ambazo zinaweza kutufikisha pale. So the reactions are taking place at room temperature ambayo ni 25 degrees Celsius. So no problem. Don't worry anything about the conditions of the reaction. Reactions are taking place at room temperature and hakuna haja yote ya kusema kwamba kuna maybe dry ether or anything. And among these reactions, they can be used in the preparation of haloalkanes. They are used in the preparation of haloalkane. So we'll see different examples of these reactions in the notes. We have different examples, a bunch of them, but this is the general idea you need to understand about these. You need to understand about these reactions. We'll have 3 of them, but all of them, their product is haloalkane. Haloalkane is the major product of these reactions. So up to here, we have finished the first group of reactions which involve hydroxyl group. Reactions which involve hydroxyl group. You have the first one, reactions which replace hydrogen, and the second one, the reactions which replace hydroxyl as well by using halogenating agents. Now in the second group of reactions, we have reactions which involve hydroxyl group and acidic beta hydrogen. Reactions B, reactions which involve hydroxyl group and acidic beta hydrogen. So acidic beta hydrogen ni nani? Remember we said in alcohol, for instance, we have CH3, CH2, C, hydroxy, hydrogen. From here, hata kama tulikuwa tuna CH3, ile carbon ambayo hydroxyl yameattach inaitwa alpha hydrogen. And from there, this is beta hydrogen. And this is also beta hydrogen. And we will not talk of other hydrogens kwanzia number 3 kwenda huko. Lakini there are some reactions which involve this hydroxy and acidic beta hydrogen. If you remember, we discussed this in mesomeric effect, I mean the factors affecting the mechanisms of organic reactions. Tulisema how hii acidic beta hydrogen, why is it acidic? Kwa sababu attraction of electrons by this tend to pull the electrons hard kwenye hydrogen which is nearby this hydroxyl group. And when the electrons they are pulled in this way, that means this bond becomes weak. And if this bond becomes weak, it will be easier to break it. Now, inapokuwa ni easier to break this bond, that means this hydrogen becomes acidic. So this is what we call as acidic beta hydrogen, and this is also acidic beta hydrogen. So it's easier to break this bond or this bond and to take the hydrogen. And most of these reactions, they are the eliminations reaction, which take the hydrogen here and hydroxyl from there, forming alkenes. Most of these reactions. So what we are saying is kwamba the reactions involving hydroxyl group and acidic beta hydrogen occur when alcohols are treated with mineral acids like sulfuric acid. However, the compound that may be formed when alcohol are treated with mineral acids depend on which reagent is present in excess. If the acid is present in excess, alcohol undergo complete elimination or dehydration to give alkene at 170 degrees Celsius, as I will discuss in the preparation of alkenes. If you remember, we said an alcohol, which is R, then COH. Let's say here we have even CH3. If we react it with conc sulfuric, then in the presence of heat, 170 up to 180 degrees Celsius, we say you will get R, C, double bond, CH2, and the product of the reaction. So, alcohol, it undergo dehydration to remove water. We'll remove one hydrogen from here and one hydrogen from here and the hydroxyl group. We'll get an alkene. So, hii hapa ni alkene, ambayo alkene inatokana nini? Na complete dehydration of alcohol, in presence of excess, sulfuric acid. So this is in case an acid is excess. Now what we are saying ni kwamba hapo tunasema kwamba if acid is present in excess, then an alcohol undergo complete elimination. If the alcohol is present in excess in the reaction, then partial elimination will take place and form ether at low temperature near 40. At low temperature near 40, ether will be formed if alcohol is excess. So kama ikiwa treated with the excess conc sulfuric acid, reaction ambayo inatokea ndio hiyo hapo kwenda kutengeneza ni alkene. But if alcohol is present in excess, this is if excess sulfuric acid is used. The excess conc sulfuric acid is used. But when it is treated with excess alcohol, partial elimination occur and ether is formed. So for example, kama tukiwa tuna 2 CH3 CH2 hydroxy, tukawa tuna conc sulfuric, conc H2SO4. Hii tu maana yake iko excess. Kwa hiyo hapa kwenye temperature ya 140 degrees Celsius, hii maana yake iko excess hapa hiyo tu. So we form CH3 CH2O, CH2CH3, ethoxyethane. So that's what you can say. Tukiwa tuna compound kama hiyo hapo, then tukiwa tuna 2 tuna conc sulfuric in temperature near 40 degrees Celsius, tutapata compound kama huyo hapa. Then hapa tutakuwa na compound kama huyo hapa. Is our product of reaction. So this is the product of our reaction. Kwa hivyo ndivyo ambavyo vitu vinakuwa vinaenda hapo. Ndivyo vitu ambavyo vinakuwa vinaenda. Kwa hiyo hizi reaction lazima unajua. Temperature 170, excess acid inatengeneza alkene. Temperature 140, excess alcohol inatengeneza ester. From there twende kwenye group ya tatu ya reaction. Hii reaction za group ya pili ndio hizo hapo. Twende kwenye group ya tatu ya hizi reactions za organic compound. Group ya tatu ya hizi reactions. Group ya tatu ni oxidation of alcohols. Here is C, oxidation of alcohols. Oxidation of alcohols. So oxidation of alcohol depends on the class of alcohol, whether it is primary, secondary or tertiary. Na pia inategemea kwenye oxidizing agent, whether it is weak or strong. I told you kwamba tukiwa tuna alcohol tukioxidize tunapata carbonyl, ambayo tukioxidize tena tunapata nini? Carboxylic. Lakini tukitoka alcohol we can apply strong oxidizing agent. Kwenda kupata carboxylic moja kwa moja. Unaona? Moja kwa moja. So inategemea. We have strong oxidizing agent such as potassium permanganate, ambayo pia tuna potassium chlorate. Hii ni mfano wa strong oxidizing agent. And hydrogen peroxide. Hizi oxidizing agent mbili zina color. Hii hapa ni purple, hii hapa ni orange. Kwa hiyo kama alcohol imeoxidize, manake color yake, kama oxidizing agent imeoxidize alcohol, color yake itapotea. Ikipotea, that's one among the chemical reactions tunaweza kuzitumia katika kutest kama hii solution ina alcohol or not. Lakini tuna weak oxidizing agents such as H2Cr2O4. Another weak oxidizing agent is MnO2, manganese dioxide, and sodium. Hizo ni mifano ya weak oxidizing agent. Kwa hiyo depending on the oxidizing agent used, whether it's strong or weak, will be having a different products of the reaction. Kwa hiyo kwanza, oxidation of primary alcohol. Oxidation of primary alcohols. Primary alcohol. Primary alcohol in the presence of strong oxidizing agent zitatengeneza carboxylic. So if strong oxidizing agent are treated with primary alcohol, carboxylic acid are formed. So tutakuwa tuna mfano R, C, hydrogen, hydroxide, then hydrogen. In the presence of strong oxidizing agent, tukiwa tuna either huyo hapa au potassium permanganate. Yani ni mifano, ila oxidizing agent mmoja tu anatosha. Kwa mimi naweza nikachukulia mfano ni muandike mmoja hapo, ngine utaona kwenye notes. Mimi namuandika tu mmoja, potassium permanganate au oxidizing agent wangu potassium permanganate, then in the presence of water, so an acidic medium. Huyu hapa tutakuja kupata RC, tutakuja kupata carboxylic acid. So a primary alcohol kama CH3, CH2 hydroxy tukamreactisha labda na hata tu hydrogen peroxide, some nice strong oxidizing agent. So in the presence of yule pale and water, we will get CH3 COOH. Kwa hivyo ndivyo ambavyo primary alcohol zinakuwa zinaenda under strong oxidizing agents. Lakini with weak oxidizing agent, we are ending up with the carbonyl compounds. Remember our equation hapa ambayo tulikuwa tumeielezea. So with the weak oxidizing agent, oxidation alcohol, primary alcohol with weak oxidizing agent. When primary alcohol are treated with weak oxidizing agent, aldehydes are formed. So to form aldehyde, for example, tukiwa tuna R, C, hydrogen, hydroxyl H, then to come treat now weak oxidizing agents such as H2, Cr2O4, then in the presence of food, acidic medium and water, tutakuja kupata R, C-O, hydrogen. And aldehyde is formed. For example, kama tuna CH3, CH2, CH2OH, tukam-treat labda na manganese dioxide. Yani hizi zote ni weak oxidizing agent. Kwa hiyo tukitumia yote ile matokeo yanakuwa ni yale yale. Matokeo yanakuwa ni yale yale. From there tunakuja kupata hydrogen ile pale, water. Tunakuja kupata CH3, CH2, COOH. Weak oxidizing agent of primary, weak oxidation of primary alcohol, we are getting aldehydes. Lakini from there, let's move to secondary alcohols. So in case of secondary alcohols in a slow reactions.